Okay, ladies and gentlemen, time to put all of this atomic structure stuff into some kind of perspective and to show you exactly how all the calculations and things work. All right, so we're going to start off with a few definitions. The first one, AMU, that stands for atomic mass unit. And so a proton, which we will abbreviate with a P plus like that, has 1 AMU of mass. A neutron, which we will abbreviate with an N0 like that, has 1 AMU of mass. And an electron, which we will abbreviate with that E negative, actually has 1 over 2,800 AMU of mass. So we can basically assume that's more or less 0. Okay? Then we have some definitions for various things. So we have atomic number, which we will abbreviate with a Z, and that is the number of protons in an element. And then we have mass number, which we will abbreviate with an A, and that is the number of protons plus the number of neutrons, because only those two things have mass. Okay? So it's important to remember that only those two things have mass. So these guys here have mass, and so they make up the mass number. All right. Now, we're just going to go through them one at a time and see how it works. Okay, so in the first one, we have 13 protons, 13 electrons, 14 neutrons. Okay, so the first thing that we're going to do is we are going to calculate the total mass. Okay, I calculate the total mass by protons plus neutrons. So mass number, or A, is equal to protons plus neutrons. Well, the protons were 13, the neutrons were 14, and so my total mass was 13 plus 14 is equal to 27. So that's my total mass. We have to remember that protons have a positive charge and electrons have a negative charge. And so the next thing that we're going to be doing is we're going to be calculating the total charge. Well, I calculate the total charge by taking the positive number of protons, because they are positively charged, and subtracting the number of electrons because they are negatively charged, and that gives me my total, or in some cases referred to as net charge. So here I have 13 protons, I have 13 electrons, so my protons is positive 13, my electrons is negative 13, so my total charge is 0 or neutral. All right, moving on to the next one. In order to calculate the neutrons, remember that protons plus neutrons is equal to mass number, right? So neutrons is going to be equal to the mass number, or total mass, minus the number of protons, or atomic number. Saying the same thing. So in this case, my total mass, or my mass number, is 25. My number of protons is 12. So my number of neutrons is going to be 25 total mass minus 12 number of protons is going to be equal to 13. And again, I'm going to do total charge by doing protons minus electrons. So positive 12 minus 10 is equal to positive 2. Now that positive 2, that is a positive ion that has a name. We call those a cation. And the positive looks like a T, and that's how you can remember that. Okay, the final one, I'm going to be calculating numbers of protons. So, number of protons. Well, in order to calculate number of protons, if I have mass and I have neutrons, remember that mass number was protons plus neutrons. So I'm doing a similar thing to what I did over here. So my number of protons is going to be equal to my mass number minus my number of neutrons. Okay, so in this particular case, I had mass number 34, neutrons 18. So 34 minus 18 is equal to 16 protons. And again, in order to get the total charge, I'm going to do what I always do. I'm going to take my protons and I'm going to subtract the electrons. So the protons is positive 16, electrons minus 18, that is a negative 2 charge. The name for a negative anion is an anion. An, negative, sounds very close together. Now, the final thing that we want to do is we want to introduce something called isotopic notation. So isotopic notation is a way of writing things in symbols that puts everything all in one symbol in an easy to understand piece. The isotopic notation is always going to be the mass will be a superscript on the left-hand side of the symbol. The protons will be a superscript on the left-hand, or subscript on the left-hand side of the symbol, and the charge will be a superscript on the right-hand side of the symbol. So we can just do them one at a time. So first I'm going to look at this one, all right, and I am going to use the fact that number of protons is equal to what we call atomic number on the periodic table. That is how we tell what kind of element we have. All right, so this particular one had 13 protons, right? So I'm going to go to my periodic table. I'm going to look for the element that has an atomic number of 13, and that is aluminum. So I'm going to write the symbol Al. The mass for this one was 27, so I will put a 27 right there. The protons was 13, so I'm going to put a 13 right there. The charge was 0, so I'm going to leave that blank. That is the isotopic notation for the first one. And I'm going to put this purple number 1 right there to show that's the one I'm looking at. Okay, second one. This has the protons of 12. So I'm going to look at the periodic table. The atomic number 12 is for magnesium. So I'm going to write Mg for magnesium. The mass is 25, so I'm going to put a 25 on the upper left. The protons is 12, so I'm going to put a 12 on the lower left. And the charge was positive 2, so I'm going to put a 2 plus right here. Now, generally, when you write charge by itself, you put a plus 2. If you put it with a symbol, it's a 2 plus, but not going to pay too much strict attention to that. That is number 2, which I'm going to put here. All right, last one. Number of protons is 16, so I'm going to my periodic table. I'm looking for element number 16, which is sulfur. So I'm going to write S as my symbol. Now, the mass was 34, so I'm going to put a 34 on the upper left. The protons was 16, I'm going to put a 16 on the lower left, and the charge was negative 2, so I'm going to put a 2 negative right there. That is my isotopic symbol for the anion of sulfur. All right, so once again, this guy right here is called an anion because it has a negative charge. And this guy right here is called a cation because it has a positive charge. That's it, folks. Hope that works for you.